Hi, my name is Jen Karson, and I'm here to introduce you to the UVM Art and AI Initiative. This is a project I launched earlier this year in 2020. Through generating images, we are experimenting with the technologies, distribution, structures, and biases and systems of style GAN and genetic algorithms. We are as interested in the processes and histories that define these technologies as much as we are interested in their potential for artistic production. We believe, as many other artists who work in AI have suggested, that because art is interpretable, tangible, and accessible, exhibiting AI art provides an opportunity to engage a lay audience in conversation and education. We'll do a brief introduction here for the team. Here is Ethan.
Hi, I'm Ethan Davis. I am a master's student in complex systems and data science at the University of Vermont.
And Sarah Pell.
I did my undergrad at UVM in computer science, and I also got a minor in studio art. And in that time, that's when I did some work with Jen and also took some classes with her and learned more about digital art. I spent another year at UVM getting my master's in computer science as well.
And then there was Fred Sanford. Don't have video of him, but shout out to Fred for all the good support he gave to this project. So there is a rich history of artists and art practices that have included algorithms and instructions. In her text Enfoldment and Infinity, Laura Marks makes fascinating connections between Islamic genealogy and new media art. Maybe it has been difficult for Westerners to find algorithm artworks meaningful because Western art is so based in figurative tradition. Western art is mimetic. There is another kind of mimesis, though, that does not imitate the forms of living things, but that imitates the process of life itself. The minor mimesis calls upon the presence of the thing being imitated, not by looking like it, but by acting like it, and thus becoming like it. And that's what's bringing us to our analogy with artificial life and why we're excited to be here today. What you're looking at here is the original artwork. These are 24 by 18 works on paper done in mixed media. These original shapes are based on a deconstruction of the old Mill Tower at University of Vermont. So this base here is an octagon, and then there's 8 triangles that stack into the tower here. When we worked with machine learning, so we started with 250 original artworks. They were digitally traced and then rotated, so that brought up our data set to about 1,500. We ran it through the Runway ML style GAN, and it created new images. This is the output of Runway ML. Sarah's going to give us a summary of Runway ML.
Using Runway ML, we were able to get a sense of what kind of results we might see later on. And it created a very quick and easy way to do that. It just kind of automates the process for you, gives you step-by-step and how you want to involve machine learning.
What you're seeing here is a program I created working with Cycling 74 Max. And it was a way to observe more closely the motion and the transitions within the latent spacewalk. Now moving on to the genetic algorithm. Ethan's going to tell us a little bit about this.
From the original data set, we extracted the individual shapes and then recombined them using a genetic algorithm in which the genotype coded for the position and size of those shapes from the original compositions. The genetic algorithm used interactive selection, so the user was allowed to guide the evolution of these compositions. We've been using this genetic algorithm to create a new data set for continued deep learning. The 3 of us have spent a lot of time individually generating these compositions with this algorithm.
And here's some output from that genetic algorithm, so you can see how it's pulled in an octagon and the 8 triangles. Here's a comparison. On the left, you're seeing output from machine learning, and on the right, you're seeing the compositions that were created using the genetic algorithm. In summary, this work is research that will inform the making of art objects and installations. If you are working on an AI or ML project that requires educational outreach, please contact us for a potential collaboration. Very special thanks to ALife 2020, Northeast Cyber Team, UVM's Computer Science Department, Office for Vice President of Research, and the Vermont Advanced Community Corps, and the UVM Humanities Center for making this research possible. To follow our project, we are routinely posting images on Instagram at Studio Juju Jen, and you can also visit our website, studiojuju.com, and we will have a Facebook page soon.